the sky. It's pretty big, right? But just how heavy is all that air? In this video, we're going to try to calculate the mass of the atmosphere and the mass of the oceans and see which weighs more, the oceans or the atmosphere. But first, what I want to show partly in this video is that we can calculate these seemingly difficult problems, firstly, generally using numbers that we already know from GCSE maths, GCSE physics, and secondly, that we're going to use approximations to calculate these quantities. And that's going to allow us to do all these calculations in our head. We're not going to use any calculator or any computing power to do this. Okay, let's go. The mass of the atmosphere. What simple equations do we know with mass in them? What about Newton's second law? Force equals mass times acceleration. So if we were going to use that, what is the acceleration we're thinking about? And what is the force? So the acceleration is the force of gravity. We know that gravity exerts a force on everything around the Earth, and we know that at the surface of the Earth, acceleration due to gravity is about 10 meters per second per second. So we're going to use that as an approximate number. Okay, so we know the force of gravity at the surface of the Earth, but the atmosphere extends out for maybe more than 100 kilometers away from the surface of the Earth. So is that going to be an issue that we need to think about? Well, probably not, because although gravity will decrease as we get further away from the surface of the Earth, the majority of the mass of the atmosphere is pretty close to the surface, and within that region that the majority of the mass resides, the acceleration due to gravity hasn't declined by very much. So I think our 10 meters per second will give us a good estimate here. Okay, so that was pretty easy. So now how about force? What does that even mean, the force that the atmosphere is exerting? The force on what? We're thinking about the force over a certain area. And again, from GCSE physics, we should know an equation that links force and area, and it involves pressure. Pressure is the force over a certain area. Pressure equals force over area. And the pressure of the atmosphere on the Earth is something that we hear all the time, on weather forecasts, on that barometer hanging on your grandparents' wall. It's roughly 1,000 millibars, and it might vary across the surface of the Earth at any given time between maybe about 950 and 1050 millibars, but so 1,000 millibars is a very good approximation. But while we're here, let's convert that to an SI unit so we can use it simply in our equation. And 1,000 millibars in SI units is 1 times 10 to the 5 pascals, the SI unit of pressure. Okay, so we know the pressure. We're trying to work out the force. So what we now need to know is the area, and that's the area of the surface of the Earth. And so we're going to make another approximation here that the Earth is a sphere. Then we're going to need to know how to calculate the surface area of a sphere, which again, GCSE maths, you'll be able to tell me is 4 pi r squared, 4 times the area of a circle. So what's the radius of the Earth? So this is maybe the only number in this calculation that is something that you might not know and something that you might have to look up. But this is a number I have in my head from geoscience practicals, and the value we commonly use is 6,400 kilometers. So we need to put that 6,400 kilometers into our 4 pi r squared. So we need to square 6,400 in our heads. And we're going to say, we know that 6 squared is 36. We know that 7 squared is 49. So 6.4 squared is going to be somewhere in between those two. And we're going to call it 40 for the sake of our estimation. And now this is where we're going to start using mathematical notation to help us think, and you might not be familiar with this. So we're going to think of 6,400 as 6.4 times 10 to the 3. When we square our times 10 to the 3, we're just multiplying that 3 by 2, we get times 10 to the 6. So now we've got our 6.4 squared, which we decided was 40, and we've got 40 times 10 to the 6. Again, in mathematical notation, we try to keep that first number as a number between 1 and 10. So 40 times 10 to the 6 is the same as 4 times 10 to the 7. So that's our radius squared, 4 times 10 to the 7 square kilometres. And we've then got to multiply that by 4 and by pi. So let's multiply that by 4, and we get 1.6 times 10 to the 8 square kilometres. And then we know that pi is roughly 3, or a little bit more than 3. And so I think a good estimate for multiplying our 1.6 times 10 to the 8 by pi is going to be 5 times 10 to the 8. And that's it. The surface area of the Earth we're going to estimate as 5 times 10 to the 8 kilometres squared. And again, now we're going to want to put that in SI units for our final calculation. And so we're going from square kilometres to square metres, with metre being the SI unit of length. So a kilometre is 1,000 metres, but a kilometre squared is 1,000 metres squared. 1,000 squared, 10 to the 3 squared, just like we just did, is 10 to the 6. So 1,000,000 metres. So we're going to go from our 5 times 10 to the 8 square kilometres, multiply that by 1,000,000, 1 times 10 to the 6, and in our mathematical notation we're just doing 8 plus 6 is 14. And so we have our surface area in metres squared as 5 times 10 to the 14 metres squared. Okay, so I think we've got all the numbers now. We just need to rearrange some of these equations and put the numbers in. So we've got our equation pressure is force over area. What we want to know is the force. So we can rearrange that to force equals pressure times area. And we've got our area as 5 times 10 to the 14 square metres. And our pressure is 1 times 10 to the 5 pascals. 5 times 10 to the 14 times 1 times 10 to the 5 gives us 5 times 10 to the 19. That's in newtons, that's the SI unit of force. So this is the force, the total force exerted by the atmosphere on the Earth. And now to calculate the mass of the atmosphere, all we're doing is rearranging our other equation from force equals mass times acceleration. We can say that mass equals the force over the acceleration. We've got our force, 5 times 10 to the 19. We're going to divide it by our acceleration due to gravity of 10. And that gives us a final mass of the atmosphere in the SI unit of kilograms as 5 times 10 to the 18 kilograms. And there we have it. Part 1, mass of the atmosphere. That large bag of nothingness weighs the same, roughly, as 1,000 trillion African elephants. So come back and watch the second video where we're going to calculate the mass of the oceans and see which is heavier, the atmosphere or the oceans. Thanks for watching.